Hello, dear students. I am Rahul Chaturvedi, and today we will cover the topic concurrent forces and application of Newton's laws of motion. So let's proceed. Concurrent forces. What are the concurrent forces? So concurrent forces are the forces that act simultaneously at the same point. What does it mean? It means that the line of action of all the forces, if passes through the same point, then you say that these forces are concurrent forces. For example, if I'm saying that there are few forces like F1, F2, and F3 are acting on a body, then if their line of action passes through the same point, means through this point, then we say that F1, F2, and F3 are concurrent forces. But if their line of action is not passing from the same point, then they will be non-concurrent forces. For example, like one force is this F1, right? And another force is F2, right? And third force, like it is, you can say here, F3. In that case, their line of action is actually not passing from a single point. So you can say that these forces F1 and F2, or you can say F1 dash, F2 dash, and F3 dash are non-concurrent forces. So for concurrent forces, we further divide it into coplanar concurrent forces and non-coplanar concurrent forces. So the condition is like this. If the concurrent forces are acting and their line of action passes through the same point and all the forces are also in a same plane. So along with the condition of passing the line of action from the same point, there is one more condition that all the forces must be in a same plane. Then you say that all the forces are coplanar concurrent forces. If their line of action you say is a same, or it can also be a different, but they are not in the same plane, then you say that they will be non-coplanar concurrent forces, right? So there is two condition actually you have seen. First, along with the line of action, so if line of action passes through the same point, then it will be concurrent forces. If line of action passes, or you can say not pass from the same point, then it will be non-concurrent forces. Right? Second case is with respect to the plane. So if all the forces are in the same plane, then you say that they will be coplanar. If just a second. So this will be coplanar, and if the plane is different, then they will be non-coplanar, right? So as shown in the diagram, all the forces F1, F2, F3, F4, and F5, they passes through the same point O, so they will be concurrent forces. But like if I'm saying these forces, you say this one is F1, F2, F3, and F4 as well as F5, they are in the same plane. If they are in the same plane, that means they will be coplanar and also passes through the same point. You say that will be coplanar concurrent. In another case, all the forces as shown in the diagram, F1, F2, F3, F4, they actually all are acting in the same plane. So they will be coplanar, but their line of action does not pass from the same point or common point. So they will be non-concurrent. So it is a combination of two different cases, coplanar, non-concurrent, coplanar, concurrent, right? Another case is non-coplanar and concurrent forces. Like in this, you say block, one force is acting P1 along the plane, upward plane. So this force is along this plane P1. Another is P2 and P3. So the plane on which these forces are acting, all these planes are different plane. So since they are different plane, so you say that they will be non-coplanar. Also, their point of action or line of action passes from a single point, and that point is O. So they will be concurrent forces. So while solving numerical problem, it will be mentioned in a question that all the forces will be coplanar, all the forces will be non-coplanar, they will be concurrent or they will be non-concurrent. So by considering these four conditions, you have to solve the numerical problems. Hope this is clear to all of you. One thing I want to mention here that for equilibrium condition, for equilibrium condition of coplanar forces, or you can say concurrent forces. So for concurrent forces, what is an equilibrium condition? So a body is actually in an equilibrium when the vector sum of all the forces acting on that body will be equal to 0. Then we say that this is that body is in the equilibrium condition. If the body is in the state of rest, then you say it is in the case it is the case of static equilibrium. If the body is moving, obviously moving with the uniform velocity, so you say that if all the forces acting on it will be 0, then you say the condition will be dynamic equilibrium. Right? So for concurrent forces, you have to check this condition. Right? For the concurrent forces, you have to check this condition, equilibrium condition, that whether the vector sum of all the forces is equal to 0 or not, right? Let's move forward. So now come to the point, application of Newton's laws of motion. So let's start with the concept of pulley. Pulley, as we know that pulley is a kind of, it's a cylindrical body, right? And one rope can pass through the center part, and that rope can move along the center part of the pulley, right? So pulley is actually, in that case, a rope is massless and inextensible, and the pulley is light, massless, and frictionless. That means we will not consider the mass of the rope. We will not consider the friction between rope and the pulley. So we have different cases like single fixed pulley. So here, pulley is actually fixed. Pulley is fixed, and one mass is attached with one of the end of the rope, right? Here mass can move. Here mass can move in the upward as well as downward direction, right? If someone is holding here, one person is standing here and he is holding the rope and he pulls the rope in towards itself. In that case, the mass will move in the upward direction. If there is no person standing here, then due to the weight of the block, this pulley, this mass will go in the downward direction. It depends on the question, right? Suppose I'm considering that mass is going in the downward direction, or you can say in the upward direction, then the tension in the rope will be same throughout the length of the pulley. So here, with the end attached with the mass, the direction of the tension will be away from the mass. Here again, at the part which is connected with the pulley, the tension will act in the downward direction. At another part, tension will act in the, again, in the downward direction. So if you have to find out the net tension here, so this net tension T dash will be equal to 2T. Since pulley is fixed, pulley cannot move, that means the net force acting on the pulley will be equal to 0. So one tension T dash is acting in the upward direction, and two forces T and T is acting in the downward direction. So net tension will be actually equal to 2T, right? Second is single movable. So again, single pulley, and it can actually move. So since pulley can move, right? Since pulley can move, you can say that tension here is T and again T. Weight is acting in the downward direction. And here, one tension T dash will act along the pulley in the downward direction, and here T dash will act in the upward direction. So for the pulley part, you can say that T dash is actually equal to 2T if, again, if pulley is in equilibrium. Equilibrium means there is no acceleration of the pulley, right? And for T dash part, you can say that for this T dash part will be equal to mg. So this is how you can balance the forces while considering that the system is in equilibrium or not. So let's solve some more cases. So how to solve the cases of pulley? First step is assume direction of acceleration. So when there is a pulley and a block, or you can say pulley and mass combination, first you have to consider the direction of acceleration. In any direction, you can assume the acceleration. At the end, if acceleration is positive, that means your assumed direction is correct. If acceleration is negative, that means your assumed direction is wrong, and the direction will be just opposite, right? Then draw FBD, that means free body diagram of all the masses. If required, solve the forces along the axis, right? Then you have to write equations using Newton's second law along each axis for each block, and then you can solve the obtained equation. So for example, in this particular case, there are two masses, M1 and M2 are attached, right? I'm considering here that the M2 mass is greater than M1 mass. Since M2 mass is greater than M1 mass, then the tendency of blocks will be like M2 mass will go in the downward direction and M1 mass will go in the upward direction. Since rope is massless, rope is inextensible, so acceleration will be same. Fine. Also, tension will be same. Right? So if you draw the FBD of M2 block, then M2 block is having actually two forces. First one is the weight of M2 block, that will be M2G, right? And T is in the upward direction, and acceleration will act in the downward direction. Here A2 is mentioned, but since acceleration will be same, so I'm mentioning here as A. In another case also, I'm mentioning acceleration is same. Fine. So if you solve this equation, you will get m2g minus t will be equal to m2 into a. So actually I am applying Newton's second law that the net force acting in the downward direction, net force will be m2g minus t. This will be equal to mass of second block into acceleration. Fine. For the first mass, since t is acting in the upward direction and m1g is acting in the downward direction, and it is accelerating in the upward direction. So the net force acting in the upward direction will be T minus m1g. And this will be equal to mass of first block m1 into acceleration. Now, if you add these two equations, you will get T will be cancelled and you will get m2 minus m1 into g is equal to m1 plus m2 into acceleration A. I'm writing here. So finally, you will get acceleration as m2 minus m1 into g divided by m1 plus m2. Clear? The same answer is written here, right? For tension part, if you put the value of acceleration in any of these equations, you will directly get the value of tension, right? So tension you will get 2m1 and m2 upon m1 plus m2 into g. So this is how you can solve the problem. One more process I want to tell you here. So there can be one more, and you can say the shortest way. So first you have to think that what is the effective force acting along the direction of motion. Since we have considered that direction of motion is downward for m2 and upward for m1. So the net force acting along the direction of motion will be m2g, right? And m1g actually will oppose the direction of motion. Getting my point? So you can say that acceleration will be equal to supporting force minus opposing force divided by total mass. So by using this concept, you can directly find out the acceleration. So acceleration will be equal to what? Acceleration will be equal to, here supporting force is m2g minus opposing force is m1g divided by m1 plus m2. You can write it as m2 minus m1 divided by m1 plus m2 into g, right? So by this process, you don't have any need to form the equation. You can directly find out the acceleration. Getting my point? Okay, so let's move forward. So there is a case that after the blocks are released from rest. So this is a combination having 2 kg and 3 kg block. So after the blocks are released from rest, calculate the acceleration of the system. Yes, only system is written here. So calculate the acceleration of the system and amount of tension in the string. Okay, so since we know that 3 kg is bigger than 2 kg, so you can say here that this 3 kg block will move in the downward direction and 2 kg block will move in the upward direction with the same acceleration. So without forming the equation, how can you solve it? I mentioned T will be same, right? So directly you can find out that acceleration A will be equal to supporting force will be 3G and opposing force will be 2G. So 3G minus 2G upon total mass, that means 3 plus 2, which will be equal to 5. Or you can say 3G minus 2G will be equal to G upon 5. Fine. And G is 10 meter per second square divided by 5. So acceleration will be equal to 2 meter per second square. Right? So no need to form the equation. Again, you may be thinking about how can we find out the tension. So for tension part, simply you can observe any of the block. If you observe the block 2, you will find here that for the 2 kg block, tension is acting in the upward direction and 2G is acting in the downward direction. And mass of this block is 2 and accelerating in the upward direction. So the net force acting in the upward direction is actually T minus 2G. This will be equal to mass into acceleration. So mass is 2 and into A. So T will be equal to 2A plus 2G. So 2A means 2 into 2 plus G is 10. So 2 into 10. So this will be 24 Newton. So tension will be 24 Newton. Right? Hope this is clear to all of you. One more question. A block A of mass 7 kg is placed on a frictionless cable. A thread tied to its one end passes over a frictionless pulley. So there is no friction in the pulley and carries a body B of mass 3 kg at the another end. The acceleration of the system, right? You have to find out acceleration. So again, use the basic concept. The concept is supporting force minus opposing force. Here, supporting force is 3G. So here, supporting force is 3G. So what will be opposing force? Just think. So maybe some of you thinking that 7G will oppose, but no, 7G is acting here and this 7G is perpendicular to the direction of motion. Direction of motion will be this one, acceleration. So since it is in the perpendicular direction, it will not oppose the motion, right? This 7G will balance the normal reaction. Fine. So 7G here is balancing the normal reaction and 7G is not opposing the motion. So supporting force here is 3G and opposing force, that means there is no force acting in the opposite direction. So opposing force will be 0. So acceleration will be equal to supporting force minus opposing force divided by total mass. So for this particular system, actually the total mass is 7 plus 3. So 7 plus 3 is 10. So this will be 3G upon 10 or 3 into 10 upon 10. So finally you will have 3 meter per second square. So this will be your required acceleration, right? So again, I'm telling you, you have to use the very basic formula that acceleration is equal to supporting force minus opposing force divided by total mass. So answer here will be B. There is one more problem. This problem actually looking complicated, but it is a very easy problem. So for a given system, evaluate the tension in each of the string. So you have to find out actually tension in each of the string which are connected the blocks respectively. So here, Here actually two strings are connected. One string is connecting 10 kg and 3 kg block, and another string is connected 3 kg and 2 kg block. So tension here will be, if I am considering in the first row, tension is T1, right? And another one here, tension is T2. Right? So let's solve the problem. So if you draw the FBD of 10 kg block, so for 10 kg block, how many forces are actually acting? The first force is acting in the downward direction. This is a gravitational force. And this gravitational force is 10g, means mg. So 10g is acting in the downward direction. You have to resolve the 10g along the inclined plane. So if you resolve this 10g along the inclined plane, you will have 10g sine 30. There will be one more force perpendicular to this plane, and this will be 10g cos 30. This will not use while solving because motion is only along the inclined plane. And one more force opposing this more force will be T1, right? So T1 is actually opposing it. So you can apply here the simple formula that acceleration is equal to supporting force minus opposing force divided by total mass. How can you solve this problem? Just think. Since all the forces actually are connected, that means acceleration will be same. Here acceleration will be same. Here is also acceleration same. Acceleration will be same. Okay. So acceleration, for acceleration part, how can you solve it? First force 10g sine 30. 10g sine 30, just form the equation. 10g sine 30 will be actually this minus T1 will be equal to 10 into A, right? Just we have to see that whether one more condition is given or not. So for this 2 kg block, if you see here, then only one force T2 is acting towards the right direction. So T2 will be equal to, again, mass is 2 and acceleration will be same, 2a. So we have two equations. By solving equation 1 and 2, we can easily find out T1 and T2. But how can you find out acceleration? So if you will form one more equation, you will have three equations by using block 3. But solving these three equations will become complicated. So you have to use this simple formula that acceleration is supporting force minus opposing force. So here, along the direction of motion, there is only single force 10g sine 30. There is no opposing force. So 10g sine 30 is supporting force minus opposing force is 0, and total mass is 10 plus 3 plus 2 for whole of the system. So total mass will be 15. So if you solve it, you will have 10 into g into sine 30. The value of sine 30 is 1 by 2. So finally you will get 50 upon 15, or this will be 10 upon 3. So acceleration will be 10 upon 3. And if you solve equation number 1, by putting all the values, you will get that T1 is equal to 10 into g sine 30 minus 10 upon 3. So this will be 50 upon 3. And T2 will be equal to 2 into A, as we have done here. So 2 into 10 upon 3. So this will be 20 upon 3. If you divide T1 upon T2, you will get 50 upon 3 divided by 20 upon 3. That means the ratio of T1 upon T2 is equal to 5:2. Right? So in the question, the ratio can be asked, but here in this question, only the values are asked. So answer will be A, 50/3 and 20/3 Newton. Right? Now, the next concept is constrained motion. So what is a constrained motion? So constrained motion means a restriction of motion or restriction of free motion of any block or any body to any direction. So if free motion of a block is restricted to any particular direction, that motion is known as the constrained motion. For example, in this rod string combination, you can see that block A and block B are attached with the rod. Since both these are attached with the block, that means there is a direction in which A can move towards B is restricted. So this kind of motion is known as the constrained motion. So here, if you can observe that when you will apply some kind of force, in that case, after some time, the displacement of the block A will be XA and displacement of the block will be XB. Since the displacement of block A and B will be equal because they are connected by a rigid rod. They are connected by a rigid rod, or you can say they can be connected by inextensible string. So in that particular case, XA means displacement of A will be equal to displacement of B. If you differentiate XA and SB with respect to time, you will get that velocity of A will be equal to velocity of B. And if you further differentiate, you will get acceleration of block A will be equal to acceleration of block B. So this is the method of solving the constrained motion. In wedge block system, so there is one wedge and one block A, right? So the tendency of block A will be going in the downward direction along the inclined plane. And since it is moving in the downward direction, so block B can move towards the right direction, right? So I'm considering that velocity of block A is VA and block B is VB. So VA, just a second. Right. So actually, due to the motion of block A and block B, you can observe here that the velocity of VA will be with respect to ground will not be along the plane. It will be something like making some angle with the vertical. Since it is making some angle with the vertical, suppose this angle is alpha, right? So you can resolve all the forces along the inclined plane and perpendicular to the inclined plane. Similarly, VB, for VB part, the angle here will be theta, right, along the plane. So VB, I will clear all the annotation. Yes, now it is cleared. So VB cos theta and VB sin theta are the two components along the inclined plane and perpendicular to the inclined plane. For VA again, you have two components, that VA sin alpha along the inclined plane and VA cos alpha perpendicular to the inclined plane, right? Getting my point? So you can observe here that VA cos theta, just a second, VB sin theta will be equal to VA cos alpha. Why? Because there is no motion along the direction perpendicular to the inclined plane. So perpendicular to the inclined plane, the block A cannot move. Since block A cannot move perpendicular to the inclined plane, that means the net velocity perpendicular to the inclined plane will be equal to 0, since it is not moving perpendicular to the inclined plane. So velocity perpendicular to the inclined plane, VA cos alpha, will be equal to VB sin theta. So by this way, you can relate velocity of block A and velocity of block B, right? Pulley string constrained motion. So for pulley string constrained motion, again, as we have seen in the previous example, A and B can be connected, like A in the horizontal plane and B is connected by the rope. And if you say that position or displacement of the block A and block B will be same, since they are connected by a massless string. So XA will be equal to XB. So if you differentiate, again, dXA upon dt will be equal to dXB upon dt. That means VA will be equal to VB. So for both the cases, if again you differentiate, you will get acceleration of A will be equal to acceleration of block B. So this is all about constrained motion. Let's solve this case. A rod moves vertically downward on the surface of the wedge as shown in the figure. Find the relation between the velocity of the rod, okay, and that of the wedge at that instant. So here, the direction of vertical motion of this rod is 5 meters per second in the downward direction, right? So this velocity will be like this, 5 meters per second, or you can write here as VA. The direction perpendicular to this inclined plane. So this angle will also, if 60 degrees theta, so I'm also saying this is also theta. So this will be VA cos theta, right? And for VB, if you say it is having one component along the direction of the inclined plane, and this angle will be again theta, and perpendicular to it, this will be VB sin theta. So here we can say that VA cos theta will be equal to VB sin theta. So as written here, that VA cos theta is equal to VB sin theta, or you can also write here as VB cos 90 minus theta. So value will be same. So VA cos theta will be equal to VB sin theta. So VA means 5 meters per second. Sin theta means 60 degree. So sin 60 degree, cos 60 degree is 1/2 is equal to VB into sin 60 degree is √3/2. So by solving it, you will get that VB is equal to 5 upon √3 meter per second, right? So next case is a weighing machine. Weighing machine, what it does? Actually, weighing machine measures your weight. How weighing machine measures your weight? If you see in two different diagram, like A and B, right? So a girl is standing here. If she put one leg on the weighing machine, so in that case, the weight is something like 25.08 kg. If he is completely standing on the weighing machine, in that case, weight is increased, and that weight is 74.10 kg. So actually, what is the role of weighing machine? What it does? So weight of the body is actually nearly constant near the surface that we know W is equal to mg. If the weighing machine measures the body weight, then in both the cases, it should be same reading. But actually, what weighing machine is doing? Weighing machine only measures the normal reaction. So weighing machine measures the contact force. So since here contact force is reduced due to only one leg is putting on the machine, so contact force is less, and in another case, contact force is high, right? So that's why, since contact force is high, contact force, which is directly proportional to the normal reaction. So this can be asked in your exam that weighing machine measures what? So weighing machine actually measures the normal reaction. So this is all about today's session. So let's connect in the future session in our by considering the next part. That in the next part we will consider the inertia forces, like what is the inertial frame and what will be non-inertial frame. So hope you enjoyed the session. Thanks for watching. All the best.